Okay, this is the Algebra 2 12.4 lesson on inverse matrices. So, in inverse matrices, first you find the, you can use the identity matrix. Okay, which the identity matrix is a square matrix. It has to be like a 2 by 2, 3 by 3, 4 by 4. And it has ones on its main diagonal and 0 for everything else. So look at this one. This is the 2 by 2 identity matrix. See how it was ones on this diagonal and everything else is zeros? Or on 3 by 3, it has ones on this diagonals and everything else is zeros. That's the identity matrices. Okay, two matrices like A and B are inverses of each other when their products are the identity matrix. So when you multiply them and you get the identity matrix, that tells you that they are inverses. All right, so the matrix has an inverse if and only if the determinant is not 0. If the determinant is 0, then it just doesn't have an inverse. And how we show the inverse is we put the letter for the matrix, in this case A, and then to the -1. That symbol right there, doing the letter to -1, means inverse. Okay, so here's the format for the matrices for finding the inverse of a 2 by 2, which at first it looks a little funky with just letters, but once we do it with numbers, I think it'll start to click. So the first thing you do is you do 1 over the determinant. And remember, we've learned how to find the determinant the other day. We take A times D minus B times C. So we learned that the other day. You just take 1 over that number. And then you rearrange the matrix like this. So look what you do. You take the A, the top left element, and switch it with the bottom right. They switch places. C and B stay in the same place, but they change signs. And so that's how you find the inverse of the matrix. Okay, let's try this. So the first thing I'm going to do is I'm going to do 1 over the determinant. And remember, the determinant was take 4 times 5 minus this diagonal 3 times 7. Okay, that's the 1 over the determinant. The determinant is that bottom number. Then you rearrange your matrix. So how you do it is you switch the A and the D. So the 5 comes up here and the 4 goes down here. And then on these two, the B and the C place, the top right and the bottom left, you change the signs. So 3 becomes negative but stays where it is. 7 becomes negative but stays where it is. Okay, so if you do just this part in a calculator right here, you have 20 minus 21, so you get -1. All right, and 1 over -1 is just -1. So you have -1 times this matrix. All right, and so if we go to try to do that, then all we do is multiply each number in here. It's like a scalar multiplication by -1. And so I'm taking each one times -1. It's changing all the signs. And this is the inverse of matrix A right here. Okay, let's do it again. All right, so you start by doing 1 over the determinant. And the determinant, remember, is 2 times 5 minus, and then do this one, 4 times 3. All right. And so if you want to go ahead and stop and do that, then you get, let's see here, 1 over 10 minus 12. So that ends up being -2. So basically -1/2 is what that is. Now you rearrange your matrix. So remember, on this main diagonal right here, you switch their location. So they switch places. On the other diagonal, they stay where they are, but they change sign. All right, so I have 2, -3, -4, and 5. Now you multiply each element by -1/2. So -1/2 times 2 is -1. -3 times -1/2 is +3/2. -4 times -1/2 is 2. 5 times -1/2 is -5/2. And that's what the inverse of matrix A is. Okay, if you want to pause and try C, you can. I'll go ahead and work through it. And if you are like feeling fine about it and you want to skip it, that's okay too. So I'm going to do 1 over the determinant, which is -6 times -3 minus 2 times 9. Okay, so I get, on the bottom, I get 18 minus 18. So what's going to happen here is I'm going to have 1 over 0 times whatever that matrices is. And because you can't divide by 0, it does not have an inverse. So c to the negative 1 does not exist. And so how you know that is if the determinant is 0, it cannot have an inverse.